Good morning, Venkat Kalyan. What about the other guys? Good morning, guys. Anyone is there in the live? I think I have started streaming early. I was just opening the things and it got started automatically. Only two people are watching. One is me and other is Venkat Kalyan. What about the other guys? Let me wait for 2 more minutes so that I'll see whether people will be coming or not. Anyone is there? Good morning, Pradeep. Good morning, Rohit. Good morning. Very good morning. What about the other guys? What about the other guys? So any doubts in the yesterday's class, anything we can talk right now because people are not there. Before and all I used to start class by 6 o'clock, but right now I started by 7 because it's winter. I think it would be difficult for you two people to wake up, so I started at 7 o'clock. Any doubts, anything? Yeah, this is the second lecture. There was some printing mistake. Instead of 2 he kept 1 only, so there is some printing mistake. This is second class. Yesterday it was first class in the steel and today it is the second class. So what I can do, what you can do, matlab kya hai Rohit? Sorry, I didn't get what you can do means solve the problems with me. That's what I can say. So there is this mistake of design of steel structures 2. If it was 2, then people might have been watching. Since it is 1, people were not available. Preparing steel design in short time. Reply me please. Yeah, I mean follow the lectures right now I'm taking, so this will be helpful if you have not studied steel till now. So this will give some basic idea of what to study, what not to study, and after that once again you revise this. I think it would be enough. It would be enough for steel. At least you will score 50% of marks. Fine guys, so yesterday we were discussing something about shape factor, plastic neutral axis and elastic neutral axis, right? So based on that concept, let's solve one more question. This is your GATE 2019 question. The question given to you is, if the section shown in the figure turns from fully elastic to fully plastic, the depth of neutral axis y decreases by. The section shown in the figure is turning from fully elastic to fully plastic. The section shown in the figure turns from fully elastic to fully plastic. This is 60 mm and this is 5 mm. Fine, this is 60 mm and this one is 5 mm. The section shown in the figure turns from fully elastic to fully plastic. He is asking what is how the depth of neutral axis decreases by. That means find out plastic neutral axis and find out elastic neutral axis. Give me the answer. Exact timing of our class from morning, if you remember, I told you from morning 7 to 9 and from evening 7 to 9. I told you yesterday I took only 1 hour of class, and so just go through the yesterday's class or message me on WhatsApp. I'll try to share the link, not a bigger issue. Try to solve this question. Only 5 people are watching and 3 people liked. People are not liking me these days. Of course it is difficult to wake up, I understand, but if you want something, you have to give up on something. I can't revise that, Rohit. It's okay. Just go through the yesterday's class. It is just some half hour of class, not a big issue. Fine. So what is the answer, guys? How much amount y decreases? The depth of neutral axis decreases. First one is to find out neutral axis or elastic neutral axis, that would be equals to centroid. Elastic neutral axis, that is equals to centroid. How you are going to find that out? Let us say elastic neutral axis is at a distance of x from the top. Elastic neutral axis is at a distance of x from the top. So centroidal distance x would be equals to, for x I'll use y bar. This is elastic neutral axis. 60 into 5, from the top centroid is 2.5, and for this one is 60 multiplied with y minus 5. From the top centroid would be 5 plus y minus 5 by 2, right? Y bar equals to 60 multiplied with 5. From the top it is 2.5. Centroid a1 y1 plus a2 y2. 60 multiplied with y minus 5. From the top centroid is 5 plus y minus 5 upon 2. Whole thing upon area. Area is 60 multiplied with 5 plus 60 multiplied with y minus 5. Right? Centroidal distance you have to calculate from the top. sorry. I think I am also sleeping. Yeah, very good morning guys. Y bar centered, how will you calculate? 60 multiplied with 5 multiplied with 2.5 for this area, and for this area it is 60 multiplied with 5. 60 multiplied with 5, from top it is 5 plus 30, right? So centroidal distance y bar would be equals to 60 multiplied with 5 multiplied with 2.5 plus 60 multiplied with 5 whole area multiplied with 5 plus 30, that is 35, whole thing upon 2 times 60 multiplied with 5, 2 times 60 multiplied with 5, that is equals to 2.5 plus 35 upon 2, 37.5 upon 2, the value equals to 18.75 mm. 18.75 mm. Y bar equals to 18.75 mm. Y bar is 18.75 mm. This is depth of equal area axis, and equal, so not equal area axis, elastic neutral axis. And next one is to find out depth of equal area axis, that is plastic neutral axis. From symmetry you can see that plastic neutral axis will be exactly here, because that is equal area axis, plastic neutral axis. How you are going to find out? Let us say this is at a distance of, let us say I don't know where is plastic neutral axis. I assume some distance at a distance of y bar, okay, some y, I'll say at a distance of y, I have to find out plastic neutral axis, equal area axis. That means area above this must be equal to area below this, that is 60 into y. 60 into y, if I have to write the area above this, 60 into y equals to 60 multiplied with 5 minus y plus 60 multiplied with 5, right? Area above this is 60 multiplied with y, area below this 60 multiplied with, this is 5 minus y, and this whole area is 60 into 5, right? So this value would be y plus 60 into y equals to 60 into 5 plus 60 into 5. So y equals to 5 mm. That's what I said. From symmetry also you can directly see that y equals to 5 mm means your plastic neutral axis would be exactly here. This is plastic neutral axis. Your plastic neutral axis will be exactly here, that is 5 mm, and elastic neutral axis equals to 18.75 mm. The difference between elastic neutral axis and plastic neutral axis is, this is plastic neutral axis, and y equals to 18.75 mm. This is elastic neutral axis. The difference between these two things is 13.75 mm. So that is the meaning of it. He is asking this difference, y of plastic elastic neutral axis minus y of plastic neutral axis, 13.75 mm. Very simple question. Fine. So any doubts in this? Any doubts in this? Only 4 people are watching. Where are the other guys? Sleeping? Rohit, this is the basic concept. Plastic analysis, we try to find out plastic neutral axis, and in elastic analysis we try to find out centroidal axis. So centroidal axis y bar is 18.75 mm and plastic neutral axis is at a distance of 13, you got 5 mm, the difference is 13.75 mm. This is your gate 2 marks question. Gate question, 2 marks question. Basics are very much important. Rohit, please go through yesterday's class, because I can't discuss everything right now. Try to understand, go through yesterday's class, and then you'll understand today's class. Okay, so if you ask me like this, what can I say? Just go through yesterday's class. It is there in the YouTube, they have not removed it. Or if you want, just send me hi on WhatsApp, I'll send it to you. What is elastic neutral axis, what is plastic neutral axis, yesterday I have discussed. So anyone who is active right now, anyone who is active right now? Only Rohit is active. 5 people are watching. Pradeep, he said good morning. I think he is busy with something else. No one is there. Venkat Kalyan said good morning, and after that he left. What happened, guys? I don't see that much enthusiasm or that much crowd over here. Anyway, next question is a rectangular steel section of width b and depth h has been stressed up to yield point up to a depth of h by 4 from the bottom, from both top and bottom fiber under the action of moment m is. He is asking what is the moment m. This is, I think this is engineering services question. This is engineering services questions. Engineering services questions, calculators are not allowed. Remember that. There is a rectangular section, fine, and in rectangular section, what he is saying is stressed up to sigma y, from h by 4 from both top and bottom. Okay, from here up to a distance of h by 4 it is stressed up to sigma y, up to a distance of h by 4 it is stressed up to sigma y. Fine, this is h upon 4, this is also h upon 4, this is sigma y, this is also sigma y. Under the action of some moment m, it is stressed up to sigma y. And what is the dimensions? B by h. B, this is b, this is h. Generally the depth of neutral axis will be at a distance of h by 2. This is h by 2, this is h, this is b. He is asking what is the value of moment m. Please tell me the value of moment m. How you are going to find out? Give me the answer. Only 2 people are watching. Even Rohit left, I think. What happened, guys? No one is there. One person, two-person. What happened? Everyone is sleeping, or you're not getting anything? Nobody is present in the class. Everything is a different experience. Anyway, so here what I can say is you have to calculate moment m. So some part is subjected to full stress. That means some part is plastic and some part is in elastic region. Fine. If I take this as the tension, this as the compression, only for this small part. So this part is in plastic region, this part is in elastic region. Fine. So what would be the depth of this part? This is h by 4. This is also h upon 4. H by 4, h by 4. That means up to a depth of h by 2. H by 4, h by 4. Fine. Up to a depth of h by 2. This behaves like a beam under elastic zone. This behaves like a beam under elastic zone. So moment due to this, generally m equals to m1 plus m2. Here I'll write m1 is elastic moment, that is Fy multiplied with Z. Z you have to calculate for a beam of depth h by 2. That means Fy multiplied with, generally for rectangular section it is BD square by 6, B multiplied with h by 2 whole square upon 6. So this is Fy multiplied with BH square upon 24. This is m1, elastic bending moment. m2, that is plastic moment. M2 is plastic moment. So in plastic moment what you will write is compression, tension. So compression or tension multiplied with lever arm. Fine. So how will you find out lever arm? If this is h by 4, lever arm would be at a distance of h by 8. This is h by 8. This will also be h by 8. I mean the centroid will be at a distance of h by 8. So overall lever arm would be equals to h minus 2 times h by 8. H minus 2 times h by 8. So compression, that is compression multiplied with lever arm, or tension multiplied with lever arm. Tension multiplied with lever arm. Fine. So compressive force, that is sigma y or Fy. You can say sigma y or Fy. Sigma y multiplied with B multiplied with h by 4. That is equals to tensile force. So sigma y multiplied with h multiplied with B by 4. Sorry, B multiplied with h by 4 multiplied with B multiplied with h by 4 multiplied with lever arm. Lever arm is h minus 2 times h by 8. So sigma y multiplied with B multiplied with h by 4 multiplied with 3h by 4. So 3bh square upon 16 multiplied with sigma y. And this is also, I'll write this as sigma y so that you don't get confused. Sigma y, this is also sigma y. So overall moment m equals to m1 plus m2. Fine. So that is bh square upon 24 plus 3bh square upon 16 multiplied with sigma y. Fine. If I take this as 48, 2 plus 9, 11 bh square upon 48 sigma y. That is the moment m. Under this moment, up to h by 4 from top and bottom, it is subjected to sigma y, and rest of the things will be in elastic zone. Fine. Any doubts? Hey Prachi, good morning. Rajnath Patel, good morning. It's not Prachi, sorry, it's Rajnath Patel. Rajnath Patel, good morning. Good morning, good morning, good morning, good morning. This is how you solve it. So first, what he is saying is, up to a depth of h by 4 it is stressed up to sigma y, up to a depth of h by 4 it is stressed up to sigma y, and this will be generally in the elastic zone. Fine. So this is in elastic zone. Total moment would be equals to elastic moment multiplied with plus plastic moment. Fine. So for plastic moment you have to find out C multiplied with lever arm, whereas for elastic moment, for this one it is elastic moment, this moment plus this moment. For elastic moment it would be m1 plus, for elastic moment it would be f sigma y multiplied with z, that is bd square upon 6. Fine. So overall it is the value of moment 11 bh square upon 48 sigma y. Any doubts? I think there are no one to ask doubts. Some mistake has happened. Some mistake has happened. (11 bh square sigma y upon 48 sigma y). That is question number . Is there anyone? If there are some persons, I'll continue. If not, I'll stop it over here because people are not there and I don't want people to miss something. Is there anyone? Please message, reply me. I think because of the name problem, many people didn't came. It's design of steel structure 1 that is given to you over there. So that is the reason many people are not available. It should be design of steel structure 2, second lecture. Please do comment, guys, if there is anyone. If there is anyone, I'll continue the class. If not, I'll stop the class. Okay guys, fine, it's okay. I'll continue the class in the evening. We'll try to take more sessions because I think many people are not there. We'll stop it over here, and in the evening we'll try to continue. Okay. Have a nice day. Bye bye.